1944. A German technical evaluation facility, well behind the lines, where the enemy's captured equipment is taken to be studied. And sitting in the workshop, hauled back from the front, is an intact American medium tank, a Sherman, waiting to be taken apart by some of the finest engineers in the world. Imagine you are one of those engineers. You have spent your career in the German engineering tradition, the finest on earth, the tradition that produced the most sophisticated tanks of the war, the Panther, the Tiger, machines of tremendous power and precision that your enemies feared. You approach this captured American tank the way a master approaches an apprentice's work, ready to catalog its flaws, confident that you already know, more or less, what you will find. A crude machine, a cheap machine, the product of a nation that builds quickly and carelessly, without the deep engineering culture that makes a tank truly excellent. And in many respects, your first impressions confirm exactly what you expected. You go over the Sherman, and you find, by the standards of your own magnificent machines, a great deal to criticize. The armor is thinner than on your heavy tanks. The main gun, for most of the war, is less powerful than the guns your best tanks carry. The tank is tall, higher than it needs to be, presenting a larger target. Its shape lacks the sophisticated sloping of your latest designs in places. Measured as a pure fighting machine, gun versus gun, armor versus armor, in a straight duel on a firing range, the Sherman is, in several important respects, inferior to your best tanks. And you note this with a certain professional satisfaction, because it confirms what you believed about the crude American approach. And then you keep looking, because you are a good engineer, and a good engineer does not stop at first impressions. And the deeper you go, the more the simple story of American crudeness begins to complicate itself, and to turn, in ways that unsettle you, into something that is not crudeness at all but a different and disturbingly coherent philosophy of what a tank is for. Because you begin to notice the other things. The way the tank is built to be manufactured easily and in colossal numbers. The way it is designed to be maintained and repaired with an ease your own tanks cannot match. The way the parts are standardized and interchangeable. The way the whole machine is engineered not to be the best tank in a duel, but to be reliable, producible, maintainable, and available in overwhelming numbers. And slowly it dawns on you that you may have been asking the wrong question about this tank all along. This is not a story about a tank. This is a forensic audit of a forensic audit, a reconstruction of what German engineers actually found and actually concluded when they took apart the American tank they had expected to despise, and discovered in it not the crude failure they anticipated, but the coherent expression of a philosophy of war that their own tradition had never fully grasped, and that was, in the end, defeating them. Part 1. The German Calculus. To understand what the German engineers concluded, you first have to understand the tradition they were judging from, because their verdict on the Sherman was shaped entirely by the values of German tank design, and those values were real and formidable and in their own terms correct. German tank design pursued excellence in the individual machine. The goal was to build the finest fighting vehicle possible, the most powerful gun, the thickest and best-shaped armor, the most sophisticated engineering. The Panther and the Tiger were the fruits of this philosophy, and they were, as pure fighting machines, magnificent. In a straight duel, a Tiger or a Panther could destroy a Sherman at ranges from which the Sherman could not effectively reply. The German tanks were more heavily armed, more heavily armored, more technically sophisticated. On the narrow measure of individual combat power, the Germans built the better tank, and they knew it, and it was true. And so the German engineer evaluating the Sherman naturally judged it by these standards, and by these standards it fell short. Less gun, less armor, a taller, less protected silhouette. The German engineer had a clear mental model of what made a tank good, and the Sherman, measured against that model, was mediocre. But the German philosophy carried hidden costs, and those costs are the whole story, and the perceptive German engineers, taking apart the Sherman, would begin to see them precisely by contrast with the American machine. The German tanks were superb, and they were also complicated, expensive, difficult to manufacture, and difficult to maintain. The very sophistication that made them formidable made them hard to build in quantity and hard to keep running. They had complex components, demanding manufacturing processes, intricate systems that required skilled maintenance. They were, in a sense, hand-built masterpieces, and masterpieces are produced slowly, in limited numbers, and are difficult to repair when they break. And this created the central German problem, the one that runs through this entire channel. The Germans could not build enough of their excellent tanks, and could not keep enough of them running, to match the flood of American machines. A superior tank that exists in small numbers and spends much of its time broken down or under repair is defeated by an inferior tank that exists in overwhelming numbers and is almost always running. The German philosophy optimized for the wrong variable, for the quality of the individual machine rather than the fighting power of the whole force over time. And it was a philosophy so deeply embedded in the German engineering culture that even a brilliant engineer, steeped in it, might take apart a Sherman and instinctively judge it by the very standards that were losing the war. That is the German calculus, embodied in the mind of the engineer standing over the captured Sherman, a magnificent tradition of individual excellence, producing superb but complex, expensive, hard to build, hard to maintain machines in numbers too small to win, and a set of engineering values so ingrained that the natural first reaction to the American tank was to catalogue its inferiority by exactly the standards that were, themselves, the German mistake. Now let us look at what the engineer found when he looked deeper. Part 2. The American Answer. As the German engineers took the Sherman apart, the thing they would have found, and the records of such evaluations, and the broader German understanding of the Sherman, reflect this, was that the American tank was not crude in the sense of being badly made. It was crude in a deliberate, purposeful, intelligent sense. It was designed to sacrifice individual perfection for a whole cluster of other qualities that mattered enormously in a long industrial war, and that the German machines lacked. Consider what a thorough engineering evaluation of the Sherman would reveal, quality by quality. First, producibility. The Sherman was designed from the outset to be manufactured easily and in enormous numbers. Its design deliberately favored simplicity of manufacture, components that could be made quickly, by mass production methods, in many factories, by a workforce that did not need the rare skills that hand-fitting demanded. Where the German tank was a challenge to build, the Sherman was engineered to pour off assembly lines in tens of thousands. A German engineer, examining the manufacturing design of the Sherman, would recognize immediately that this was a machine built to be built, optimized for production in a way that his own tanks were not. Second, reliability. The Sherman was, by the standards of the time, and especially by comparison with the complex German machines, notably reliable. It broke down less. It could travel long distances under its own power without failing. Its mechanical systems were robust and dependable. For a German engineer accustomed to the maintenance-hungry sophistication of the Panther and Tiger, the sheer dependability designed into the Sherman would have been striking. A machine that kept running, that did not constantly demand the attention of skilled mechanics, that could be relied upon to work. Third, maintainability. When the Sherman did need repair, it was designed to be repaired easily. Its components were accessible, its parts were standardized and interchangeable, so a broken part could be swapped for an identical replacement quickly, by an ordinary mechanic in the field. Where a damaged German tank might need to be recovered to a workshop and worked on by specialists, a damaged Sherman could often be fixed forward, fast, and returned to action. The German engineer, who knew intimately how hard his own tanks were to repair, would have seen in the Sherman's maintainability a deliberate and valuable design priority. Fourth, the crew and the practical qualities. The Sherman was reasonably comfortable and workable for its crew, reliable to operate, and equipped with the practical features, the good radio in every tank, the reasonable ergonomics, the workable fighting environment, that made it effective in use even where it was outmatched in pure firepower. And it was fast and mobile, well suited to the war of movement. And here is the synthesis that a truly perceptive German engineer would reach, and that the deeper German assessments did reach. The Sherman was not a failed attempt to build a Tiger. It was a successful attempt to build something entirely different. A tank optimized not for the duel but for the campaign. not for the individual battle but for the long industrial war. It sacrificed the qualities that win a single engagement, maximum gun, maximum armor, for the qualities that win a long war, producibility, reliability, maintainability, availability in overwhelming numbers. It was a coherent, intelligent, and ultimately superior answer to the actual question the war was asking, which was not which tank wins a duel, but which nation can put the most working tanks in the field and keep them there, month after month, year after year. The German engineer had approached the Sherman expecting to find crudeness, and the deeper he looked, the more he would have found instead a machine that was crude only in the way a tool is crude, deliberately simple, robust, and fit for purpose. And that embodied a philosophy of war that was beating the German philosophy not despite its apparent inferiority, but because of the very qualities that looked, at first glance, like inferiority. The Germans built a tank to win a battle. The Americans built a tank to win a war. And the German engineer, taking it apart, would slowly have realized which of those was the harder and more important thing to build. Part 3. The River of Steel. What the German engineers found in the Sherman was, in miniature, the entire American way of war, and it connects to every theme this channel has developed, because the Sherman is that philosophy cast in steel. It connects to interchangeability and mass production. The standardized, interchangeable parts that made the Sherman easy to build and repair were the same American system of manufacturing that ran through the whole war effort, the philosophy of the identical, swappable part that we have examined in its own right. The Sherman was that philosophy applied to a tank, designed for mass production, built from standardized components, maintainable by the swapping of identical parts. It connects to reliability and the whole theme of keeping machines running. The Sherman's dependability and its ease of repair meant that a high proportion of Shermans were running at any given time, while a lower proportion of the complex German tanks were. We examined this in the story of recovery and repair. The Sherman's design was the front end of that whole system, a machine engineered to break down less and to be fixed faster, so that the fighting power of the force was preserved. It connects to the theme of quantity as a quality in its own right. The whole point of the Sherman's design was to enable overwhelming numbers, and overwhelming numbers are not merely a quantitative advantage but a qualitative one. They change what is possible, allowing the concentration of force, the acceptance of losses, the maintenance of pressure everywhere at once. The Sherman was designed to be numerous, and its numerousness was itself a war-winning quality that its individual mediocrity was the price of. And it connects to the deepest theme of all, the American understanding that a long industrial war is won by the system, not by the individual masterpiece. The Sherman was a systems tank, designed as one component in a vast system of production, supply, maintenance, and replacement, optimized to make that whole system work, rather than to be the finest possible individual machine. The Germans built masterpieces and lost. The Americans built systems and won. And the Sherman, sitting dissected in that German workshop, was the physical proof of the difference. A machine that any German engineer could see was inferior in a duel, and that the most perceptive German engineers could also see was winning the war, precisely because it had been designed for the war and not for the duel. The German engineer, standing over the disassembled Sherman, was looking at the answer to a question his own tradition had never quite thought to ask. Not how good can we make one tank, but how do we build a force that wins a long war? And the Sherman answered that question so well that it was beating the finest tanks in the world, not on the firing range where it lost, but in the only place that ultimately mattered, which was the vast, grinding, industrial totality of the war. Part 4. The German realization. The German realization, distilled from what the engineers found in the Sherman and from the broader German experience of fighting it, was one of the most sobering understandings available to a thoughtful German by the later years of the war. At the level of the individual engineer, the realization was that the Sherman was not the crude failure it first appeared, but the intelligent expression of a different philosophy, and that this philosophy was defeating the German one. The engineer who took the Sherman apart expecting to feel superior might well have finished the job feeling something closer to unease, because he would have seen, in the deliberate design choices of the American tank, evidence that the enemy understood something about industrial warfare that the German tradition, for all its brilliance, had missed. And at the broader level, German commanders and engineers came to understand the terrible arithmetic that the Sherman embodied. It did not matter that a Tiger could destroy several Shermans before being destroyed itself. If the Americans could build 10 or 20 Shermans for every Tiger, and keep them running, and replace their losses effortlessly, while every Tiger lost was an irreplaceable catastrophe. The exchange rate on the battlefield favored the German tanks. The exchange rate in the war as a whole favored the American tanks overwhelmingly, because the war was decided not by the outcome of individual duels, but by the totality of production, reliability, and numbers over time. The Germans won tank battles and lost the tank war, and the reason was designed into the Sherman. There is a famous and terrible sentiment that circulated among German tank crews, the grim acknowledgement that their superior tanks were simply overwhelmed by the sheer numbers of the enemy's inferior ones, that killing 3 or 4 or 5 Shermans meant nothing when another dozen appeared behind them. This was the Sherman's design philosophy working exactly as intended, felt from the receiving end. The American tank was engineered to be numerous and available, and its numerousness and availability ground the magnificent German machines into the earth, no matter how many individual duels the German tanks won. And the deepest German realization, available to the most perceptive, was the one this channel keeps arriving at. They had been beaten not by a better tank, but by a better understanding of what a tank was for, by an enemy who had grasped that, in a long industrial war, the producible, reliable, maintainable, numerous machine defeats the magnificent, complex, rare one, however superior the rare one is in a duel. The German engineer who took apart the Sherman and found it inferior on the firing range, but superior as an instrument of industrial war, was confronting the failure of his own tradition's deepest assumption, that the best tank is the one that wins the duel. The Americans had understood that the best tank is the one that wins the war, and those are not the same tank, and the difference between them is written into every deliberate compromise of the Sherman's design. The German engineer, standing over the dissected American tank, understood at last that he had been judging it by the wrong standard all along, and that the enemy who built it had been judging tanks by the right one. If your father, your grandfather, or your uncle crewed a Sherman, or built one in the great American factories, or repaired them and kept them running at the front, I would be grateful to hear his name and his unit in the comments. The Sherman crews fought in a tank that was often outgunned by the German machines, and they knew it, and they climbed in and fought anyway, and they won. Not because their tank was the best in a duel, but because there were always more of them, always running, always coming. That took a particular kind of courage, and it deserves to be remembered. They are mostly gone now. What remains are the stories their families carry. Those stories belong in the record. Part 5, The Verdict, 1945. The war ends, and the Sherman, the tank the German engineers had expected to despise, has helped win it, not by being the best tank on any battlefield, but by being the right tank for the whole war. So here is the verdict, and it is the verdict the German engineers themselves reached, reconstructed from what they found in the machine. The German engineer approached the captured Sherman expecting crudeness, and by the narrow standard of the individual fighting machine, he found it. Less gun, less armor, a taller silhouette, inferiority in the duel. And had he stopped there, he would have confirmed his prejudice and learned nothing. But the good engineers did not stop there, and what they found when they looked deeper was not crudeness, but a different and coherent philosophy. A tank deliberately designed to sacrifice individual perfection for producibility, reliability, maintainability, and overwhelming numbers. A machine optimized not for the duel, but for the long industrial war. A coherent and intelligent answer to the real question the war was asking, which the German tradition, for all its brilliance, had failed to ask. The German engineer who took apart the American tank was making, in miniature, the discovery that his whole nation was making the hard way across the whole war. He had built masterpieces and was being beaten by tools. He had optimized for the quality of the individual machine and was being defeated by an enemy who had optimized for the power of the whole force over time. He had asked how good a tank could be, and the enemy had asked how a tank could help win a war, and the enemy's question turned out to be the one that mattered. The Germans built the better tank. The Americans built the better weapon of war, and the German engineer, standing over the dissected Sherman with his catalogue of its inferiorities in one hand, would slowly have understood, in the other, that every one of those inferiorities was a deliberate price paid for a superiority that his own magnificent tanks did not have and could not match. The superiority of the machine that can be built by the tens of thousands, kept running, repaired in the field, and sent forward, always more, always available, until the finest tanks in the world are simply buried beneath the sheer unstoppable numbers of a tank designed, from the first bolt, to win not the battle, but the war. The Germans could build a tank that won the duel. The Americans built a tank that won everything else. And in a long war, everything else is the only thing that counts. If this forensic audit gave you something to think about, hit the like button. It keeps this channel visible to the people who want the history the way it actually happened. Subscribe if you want the next audit, because there are more of these, more systems, more decisions, more of the invisible, unglamorous machinery that decided who won and who came home. And remember this about the tank, that was not the best. Nobody makes a film about a machine designed to be merely good enough, reliable, producible, repairable, numerous. The films are about the tigers, the great cats, the magnificent predators. And they were magnificent, and they were more powerful, and in a straight fight they won. But war is not a straight fight. It is a long, grinding, industrial totality, and it is won by the boring virtues, by the machine that can be built and built and built, that keeps running, that gets fixed and comes back, that is always there in numbers the enemy cannot match. The Sherman was that machine, and the German engineers who took it apart understood, if they were honest, that its apparent mediocrity was a kind of genius, the genius of building exactly the tank a long war requires, rather than the tank that looks best on a firing range. Mostly, the Sherman was there, and running, and coming, and in the end, that mattered more than being the best. They deserve to be remembered, the crews, the builders, the mechanics of the tank that was not the best, by the hard and unglamorous truth that the German engineers themselves came to understand over their dissected Sherman, that the machine designed to win the war beats the machine designed to win the battle, and that there is a deep and difficult genius in building, on purpose, a tank that is merely good enough, in numbers that are simply overwhelming.